first topic is static fluid. I believe that you already know about example of fluids. So the fluid is consists with two types of material. The first is in a liquid, and the second one is gas. So both of them we call as fluid. So fluid is mostly is sometimes liquid and sometimes is in gas. Okay. And today we will discuss about static fluid. Why we divide it into two sessions? Because the type of the static and dynamic fluid have so many different ways to explain. We know that dynamic fluid will have a flow according to its channel, and the static fluid they will remain stay inside of the place of the channel. So we can see that in static there is no movement in physically, but in a molecule there is still any movement of the molecule of the fluid, both in gas or in liquid. But when we saw, for example, if you go to some nice place like a lake or some pool, and there is no one go inside the lake or pool, so we can see the water will remain calm and no flow anywhere. In this case, we can see that this fluid condition will be no flow and will be remain in its place. So it's called as static. So when there is no movement, we call it static. But if there is a flow, like in the river or in the sea, the fluid will be dynamic. And we can see so many phenomena in fluids, both in gas or in liquid. For example, I believe, do you know this one? This is a gas balloon. So when you give the inside of the balloon some type of gas, usually using carbon dioxide or sometimes using hydrogen gas, and you give a small burn, so the gas balloon will be moved upward because the gas inside the balloon was expanded, and it can be rise up and also bring some passenger inside. In this case, this is also the fluid phenomenon. The other side, if you have an egg, sometimes you put your egg inside a bowl or a glass. Sometimes the egg was floating, but sometimes was sinking until maybe touching the bottom side. But sometimes the fluid was fly or submerged between the surface and the bottom. It depends on your egg condition. Sometimes a good egg was floating between the surface and the bottom. But sometimes the bad egg, maybe it's already too long, you keep in your house or in your refrigerator. Sometimes the egg was broken. So when you put the egg inside the water, it will be floating until the surface. So that's the simple way how to separate which is the good egg and a bad egg. So if you buy many, for example, 5 kilograms of eggs. You want to separate which one is good and bad. Just put inside the water, and you can see which is the egg was floating on the surface. The floating egg in the surface, it is the broken one. So please do not consume that egg because it's already broken or sometimes expired. But if the egg was inside the water, sometimes sinking or sometimes floating between surface and bottom, this is the good egg. That is a simple way. The other one is some insect. I don't know what is the name of this insect. Long time ago, many times I see this insect at the sometimes rice field. So when the rice field was filling by the water for irrigation, I see this insect was floating on the surface of the water, and this insect cannot be sinking. It can be moved easily at the surface of the water without sinking. Long time ago, I don't know why this insect can do like that, because I cannot. Maybe if I put my leg into water, I will be directly sinking. But this insect they can stand and stay at the surface of the water. So this is some of phenomena of fluid phenomena. In our first discussion about static fluid, so the environment of the static fluid will be limited in its place. For example, for the gas balloon, so the environment of gas balloon was limited of inside of the balloon, and this volume of the gas will be not coming out, or something from outside coming inside. Also, if you fill some water or some fluid inside the glass, so this is the environment or limited environment for the static fluids. And the fluids cannot, it's easy to change its shape according to the place. And also some fluids cannot resist. It cannot resist and stay above the shear force. That's why when we discussed previously about the density of material, when you saw the shear modulus of some fluid, there's empty. The value of shear modulus of fluid condition, because fluid cannot resist the shear force. And inside the static fluid, we found the potential energy about the fluid, and also some special force inside the fluid we call as the hydrostatic force. Every fluid will have this hydrostatic force. So if we say about hydrostatic, so this is force inside the fluid, and the condition of fluid is in liquid, because in gas there is no piston, there is no hydrostatic. So for liquid, But in gas, there is a different term we call as pneumatic. So the hydrostatic only for liquid, but for gas there will be pneumatic. So it's have a different parameter. For the liquid, why it has a hydrostatic? Because the liquid was incompressible. Liquid was called as hydrostatic because it has parameter incompressible condition. So when you give a force to the liquid will be spread or give to another area, another point of the same amount of the force. But in gas, in pneumatic condition, the gas condition was compressible. So you can fill so many volume inside place of the gas without the gas was expanded anywhere. For example, we can see some of like your motorcycle tire or sometimes car tire. You can give you can add some volume of gas, and the pressure inside the tire will be higher, but the volume will be similar. But if you give more and more, your tire will be lower because the tire will be high pressure inside. But you cannot do the same way into the liquid. If you fill your tire with liquid and you give pressure to the liquid inside your tire will be easily to blow up because liquid was incompressible. It will find a way how to separate and distribute the force. So this is the difference between the liquid and gas. In a liquid condition, we can verify using some experiment, and based on those experiments, we can see that the molecule of the fluid are loosely bonded to remain close together. It's easy to change the bonded molecule, but it's also easy to gather with another molecule in liquid molecule. And also in liquid condition, when the pressure arises, so it will also give a same value of the force in every circumstance. And the pressure in a liquid was perpendicular to the surface. So this is also we call as a normal pressure. And in gas condition, gas fluid condition, the molecules are easy to move freely, and it's also easy to collide, sometimes friction with another molecule of gas. And the level of the movement of gas compared with the liquid is the gas is easiest. The molecule is easiest to move everywhere compared with liquid. For the solid, the molecule will be stay with the bonding another molecule. It's difficult to moving for the solid condition. And also for the pressure condition, the liquid was perpendicular to the surface. It's also same condition. In a liquid condition, we will call as a hydrostatic pressure. We will formulate the pressure of hydrostatic. We can get from the basic equation of the pressure. Basic equation of the pressure, we also use this equation in our previous lecture class. So the pressure was equal to force divided by cross-section area. This is the basic equation. From this basic equation, we can differentiate into another form. Because force we can get from mass crossed by gravitation acceleration. So force was get from mass crossed by acceleration gravitation divided by cross-section area. And mass we can also get from the density was equal to mass divided by volume. So we can get for the mass was from density crossed by volume. So we substitute the mass become the rho or density crossed by volume, and don't forget this is the gravitation acceleration divided by cross-section area. Density and gravitation acceleration will be not changed for the density and gravity, but volume and cross-section area sometimes change according to the place or the shape. So volume divided by cross-section area, we will have the h, and the h was distance. But please pay attention, the distance of the hydrostatics was measured from the surface, not from the bottom. So the h, this is the distance, was measured start from the surface of the liquid. So for example, if you put some box, some material inside the liquid, for example in this point, so the pressure in this point you will get from the equation density crossed by gravity and crossed by h. H was distance, and this distance will be measured from the surface. So when you change the distance of this material deeper inside the liquid, so because the equation was rho, k, and h, so when you move this material deeper inside the liquid, so the pressure also will be rise. That's why when you're swimming, maybe for human normal condition, maybe you can only swimming maybe 10 meters. After that, if you insist go diving deeply, maybe you will feel very hard into your ear because the pressure of the water will be rise because of this equation. So if you dive deeply, your body will have a pressure more high pressure when you goes deeply. So the pressure will be attack your body, especially your soft body. For example, your ear membrane. This is some of your soft organ, and also your eyes. This is also soft organ. So the pressure firstly will be impact to your soft organ. That's why if you go diving, you have to use some special equipment for diving. For example, like earplug, special earplug for diving. So, and you also bring some pressure gauge, so you know where is the limit of the pressure when you dive safely. So your body will be safe when you dive. Okay, do you have any question for the hydrostatic pressure? Hydrostatic pressure was equal to rho G and H. So in the same level, in the same distance from the surface, so the pressure will be similar. If you change the position in this point, or any point, but the same distance from the surface, the pressure also will be similar. But if you go deeper, the pressure will be higher than before. Another example of the hydrostatic fluid is you put two types of liquid, for example, water and oil. If the oil density is higher than water, so the oil will be stay at the bottom, then the water at the outside. But if the water density was bigger than the oil, so the water will be filled or stay at the bottom than the oil. In this condition, if we put two types of liquid in some place, it is also has a different pressure according to the depth from the surface. We know that the pressure comes from rho, G and H, but since this is two types of the liquid, for example water and oil, so the pressure will be divided into two types, P1 and P2. And the P1 and P2 was separated with the specific distance from the surface of the liquid. So we have to divide into one by one. For example, P1 we will get from rho, G and H1, and P2 we will get rho, G and H2. So because this is two types of the liquid. This is the example. A cylindrical drum with a 50 centimeter radius, and the top of the drum was open, and the drum was filled with kerosene up to 80 centimeters. if the density of kerosene is 0.8 gram per centimeter by 3, it means that if 0.8 is less than water density, because water density 1 gram per centimeter by 3, but the kerosene is less, 0.8 gram per centimeter by 3, and the external pressure is 1 atm. So this is the kerosene, and the top of the drum was open. So this is also some pressure from the atmosphere pressure. And inside the drum, because it is filled with the kerosene, so this is the hydrostatic. This is the hydrostatic pressure, and outside was the atmosphere pressure. And the atmosphere pressure was 1 atm. Calculate the pressure at the base of drum. So if this is the base of drum, and the drum radius was radius. So it will be 100 centimeter for the diameter. And was on the width of the kerosene 80 centimeter. Calculate the pressure at the base of the drum. So this is A. Pressure at the bottom of the drum. And B, the hydrostatic pressure at point located 10 centimeter from the drum base. So for example, this is B point, and B point was 10 centimeter from the bottom, pressure from the bottom. So a drum filled by kerosene, and you have to find how many pressure at A point, it is at the bottom, and how many pressure at the B point, it is 10 centimeter from the bottom. And there is two types of pressure, atmospheric pressure and hydrostatic pressure. For the answer of the A, in A was asking about the pressure at the base of drum. Because the pressure, if A only A was asking about pressure at the base, it means that total pressure, it consists of atmosphere and hydrostatic pressure. That's why at the B, at the A, or at the bottom of a drum, the pressure was divided into two types, hydrostatic and atmospheric pressure. And the hydrostatic was get from rho, G, and H. And rho is density for the kerosene. Density of kerosene was 0.8 gram per centimeter by 3. So we transfer into kilogram per meter by 3, meter cubic. So it's become 800 kilogram per meter cubic. And the gravitational acceleration, we use 10. And the tip, and this is the tip at the bottom, is 80 centimeter. So we must change to the meter, so it becomes 0.8 plus 1 atm was equal to 1.03 multiplied by 10 by 5. So we can get the total pressure at the bottom of the drum is equal to 1.094 multiplied by 10 times 5 Newton per meter square. So this is the pressure at the bottom equals to 5. And the second, P, the hydrostatic pressure. So this is only hydrostatic pressure. It means that only pressure inside the liquid. No need calculate with the atmosphere. We only asking about the hydrostatic pressure at point located 10 centimeter from the bottom. So we can use only the hydrostatic pressure. Rho, G and H. Rho is 800, similar with this one, multiplied by 10. This is the gravitational acceleration. And H, 0.7. Why 0.7?
10 meter, 10 centimeter above the base.
Measure from
the bottom.
From the bottom.
Or from the surface.
Yeah, because the point from the bottom up is 10 and we will make like 80 minus 10, that's equal 0.
Yeah.
Because we should like from the surface like down, not from the bottom up.
Yeah, you're right. So the H was measured, just remind that H will always measure from the surface, not measure from the bottom. That's why if this is 10 centimeter and the total depth of kerosene was 80 centimeter, so it means that H was 80 minus 10. So it will be 70 centimeter or 0.7 meter. So the hydrostatic pressure at this point, point B, will equal to 5,600 Newton per meter square. So this is pressure at the B point. So in this equation, you just remember that the pressure was equal to rho G and 1,000 kilograms per meter cubic. So it means that the water is more weight than oil. So the water will stay at the bottom, and upside was filled by the oil because the density of oil is less than water. Then determine the amount of pressure experienced by a point at a distance of y 0.25 meter from the bottom. So the y point is 0.5 meter from the bottom. And take H1 1 meter. Take H 1 meter, H1 and H2 equal to 0.5. So this is total of H, and this is half of H, and same length, same depth, 0.5. And the surface, cross area surface of this glass or this cylinder was equal to A equal to P per 100 meters square, and the gravitational force was 10 meter per square inch square. So the question determine the amount of pressure at the point 0.25. Zero, this is the point. The point is 0.25 meter. One of the scientists to explore about the liquid phenomena is Pascal. The scientists have some important result of his study. The first that result, the pressure applied to confined fluid is transmitted undiminished to every part of the fluid and the wall of the container. This is according to Pascal experiment. He said that if you give some force to liquid, and the force will be transmitted into everywhere inside of the water with the same value. That's why the liquid we call as incompressible, because we cannot give some compression to the liquid. Liquid will be find a way how to separate and distribute the compression. So this is also finding from the Pascal. Pascal found that if you give the power pressure to the liquid, so the pressure will be transmitted into every part of the liquid and also to the wall of the container in same value. And according to Pascal, pressure applied to the fluid in a closed space is transmitted equally in all directions. It means that this statement equally, it means that if you give 5 Newton of force, so the same value 5 Newton also transmit into everywhere inside the fluid liquid. This is according to Pascal study. So that's why if you make 2 channels of a place and you filling the channel with some liquid, for example using water, for example, if you give pressure in a small channel, so it will be comes out into the other channel. Also, if you give pressure from the bigger side of channel, the same amount of the pressure will be comes out from the small one. So this will be same pressure. So pressure in 1 equal to pressure in 2. 1 is small, 2 is biggest one. So this is the small one, small channel, and this is the bigger one. And because pressure was equal to F per cross-sectional area, force you give from external force. So if you give force to this side, the other force will be comes from the other channel. So F per A will equal to small f. Small f was in this small channel. F capital is from the bigger channel. So small f was divided by cross-sectional area. This is the cross-sectional area, and for the small channel, and this is for the bigger channel. So using this equation ratio, you can get how many force in every point inside the channel. You can use this equation ratio. And this principle nowadays was using in a hydrostatic equipment. For example, using for the hydraulic check. If you have maybe a motorcycle, you don't need hydraulic check. But for your car, for example, if you change your tire because your tire was flat, you need the hydraulic check to help you lift your car and change your flat tire. But sometimes maybe the modern car now not using hydraulic check because maybe the hydraulic check was expensive but powerful, expensive, and also we have to maintain the fluid inside the hydraulic jet and some part of the hydraulic jet. So nowadays modern car not using hydraulic jet. They change using mechanical jet. Usually the shape of the mechanical jet hydraulic was like this. Now modern car using this type of check. This is not hydraulic check. This is only mechanical check. You just put some put this jack at the bottom of your car, and you screw this side usually using some long bar. And you grab this bar, so this mechanism will be upside and go downside. Now using this one because this part no need maintenance. Maybe you can put some grease in this form, in this worm here, and the grease will be long lasting. Maybe until 5 years, you change by this component, mechanical check. Long time ago, my father has car equipped by this small check. But now the modern car not use that part again. And the principle of the hydraulic check was using this Pascal principle. You give small force into the small channel. So if you give a small force in this area, the small force will be transmit into the bigger chamber. So if this is the small chamber, so by pressing the lever, you give the small force in this chamber, and the bigger force will become at the bigger chamber. Using this Pascal principle, you give the small force in small chamber, you get the bigger force in the bigger chamber. So the small force, maybe normally for a human, give a force by your hand. But the force comes out this chamber will be maybe 10 times or more than the human force in this side. So it can be lift any heavy things, for example like car, maybe the average heavy of car now maybe almost 1 ton, maybe 1 ton. Some big car maybe have a weight 1.3 ton, but a small car maybe maximum 1 ton or maybe less than 1 ton. So you give small pressure, you will get a bigger pressure. You can lift the bigger equipment such as your car, so you can easy to change your tire. Without these tools, mechanical or hydraulic jack, maybe you cannot change your flat tire. It's heavyweight. If you lift by yourself, maybe you cannot. Even I cannot lift my car. I need special to help change the flat tire. Okay, we go to the next. In a liquid condition, there is some hydrostatic paradox. This is also found by Blaise Pascal. If you have some chamber like this, in this area you have a triangle chamber or taper chamber. In this, the other side, you have a oblique chamber like this, and the other side there is a normal chamber. If you fill some liquid, for example water, in every chamber, you fill the liquid inside the chamber, you will get that the surface level of the liquid will be same, even if the shape of the chamber is different. The surface of the water will be stay same, even if this chamber is a taper, this is the oblique, and this is the normal straight, vertically straight. All the surface level will be similar. So Blaise Pascal called this condition as the hydrostatic paradox. And because of this phenomena, we can use this phenomena useful, especially for building building house or office or big building some field using this hydrostatic paradox. So this is the simple or maybe the easy way how to measure the same level of building level. For example, if you want to give some mark in this area, for example, you want to put some ceiling from this side until that side and that side, you have to know what is the level. Measure from the bottom of the tile. Sometimes there is a difference because sometimes building tile was maybe there is some angle. So if you measure the ceiling from the tile, maybe in this height of the ceiling, and those height of the ceiling will be some different. So how to get the same level of the ceiling? By using this phenomenon. Sometimes the carpenter or some building expert sometimes using the small elastic pipe, and he filling with water. So for example, in this side I bring one of the pipe, elastic pipe, and my friend hold the other side, also bring the same pipe. So you have bring a long elastic pipe. What is we call elastic pipe? In Indonesia we call it slang. What is in English?
Hose.
Elastic hose. Yeah, elastic hose. Yeah. So the first person bring the elastic hose, for example, in this area, and the other was at the other area also, and filling the water. Filling the water until the level of the water is same. If you use this area as the base point, for example, if you fill it, then you find the level. Oh, this is the level. You make some mark in this area, and the other side, the other person also using the same. If the level in this area already set, the other ones will easily, oh okay, this is the level, so the other side will be used also the same mark. So the level between in this area and in this area will be similar. Even if the elastic hose was maybe sometimes not straight bending, sometimes was bending, or maybe yellowing, split out, it's no problem. As long as this hose was connected with just filling water. So it will guarantee that the level of the sailing in this side and those side and the other side will be same. Also, if you build this building and the other building, I believe that the land in this building and those buildings will be different contour, different level. But using this hydrostatic particle, we can get that the 1 meter and 1 meter at another building will be similar. That's why this is also by the building contractor to build the level of the high building using hydrostatic diagrams. And also the other some special equipment we call as water pass. Do you know water pass? Do you know water pass? This is also a special tool using by the build constructor, like a ruler. Even if you change the other shape of the chamber, the level of the water or liquid will be always similar. It's called hydrostatic dynamics. Yeah, yeah. So the liquid or water has the special ability to help human, especially to help human to measure the level of the hydrostatic condition. Sometimes we using to build some building or some construction, how to measure the level of the construction using this hydrostatic pressure. This is one of the liquid ability. The other with liquid also have a special ability to identify the material inside the liquid. Human didn't have this special ability. For example, if I give you one metal, I have two metal, I give to you, please identify what kind of metal. Maybe you can guessing by see the color, see the texture, see the maybe mark or something else to the metal. But you cannot give a specific value or parameter to this metal. But liquid can do that. It can differ. It can spread. This is the same metal or different metal. Liquid can do that. So I will give you the story. I will give you the story. Oh, the other one is the other scientist. Beside Pascal, there is a Archimedes. Archimedes also interested to study about the liquid phenomena. Not only liquid, but also gas. So, according to Archimedes, every liquid has a special force. He called the force as a buoyant force. So every liquid has a buoyant force. For example, person swimming, they can ride into the small boat and they can floating at the surface of the water. This can happen because the water has a special force to lift you up into the surface of the water, and the force was called as a buoyant force. And also, if you go to the Dead Sea has a highest salinity level, so the water of this was very salt, and I think no one, animal or plant, water plant, live inside the Dead Sea because the salt level was very high. So the person swimming at the Dead Sea, it's easier because the body will be easy to floating because the water has a highest salinity level. It means it's very, very salt. You cannot drink from this sea. It's maybe yeah, even I never try the smell of, maybe Ahmad, did you ever go to the Dead Sea?
Yeah. To see, we have seen, we call the place like Maha, and we have
Oh,
yeah.
Yeah.
And also the taste is so salty.
Very salt.
Yeah.
Did you ever go to the Dead Sea?
Yeah, I go to the sea, yeah, and we can swim.
Yeah.
I can swim in the sea.
Maybe from Yemen it's near.
Yeah.
Yeah.
It's near.
That's why In a high salinity especially, person is easy to swim because the buoyant force was very high. So every liquid has a buoyant force. And how to measure the buoyant force? Buoyant force was equal to Fp, it means the buoyant force. And according to Blaise Pascal, and this is the formulation of Blaise Pascal, rho, g, and h. This is the formulation of Blaise Pascal, hydrostatic pressure. But for the buoyant, almost similar, rho, g, and a and h, which is a and h was equal to the volume. So it's also rho, h, and volume. This is the buoyant force. But the volume changes into cross-sectional area multiplied by the depth. So the buoyant force equal to rho, g, and volume. This is based from Archimedes' study. Also Archimedes was asked by the king. There is a king. Archimedes was asked to find out whether the newly made king's crown was really made of gold or not. So the king was, he wants to make a new crown for herself. So he asking to the other craftsmen to make the crown from the pure gold. So the king gives the gold to the craftsmen to build it into the crown. After several times, the craftsman comes to the king and give the new crown. But the king was doubt. He afraid that the new crown was not made by pure gold given by him to the craftsman. The king wants to prove this crown is same way with the gold given to the craftsman or not. So the king called Archimedes. Archimedes, please come here. I need your help. Please find this new crown for me made by the craftsman. Is it the same gold, the same weight with the gold I give to the craftsman? Because I am afraid that some of my gold was taken by the craftsman and not all of the gold made into the crown. So the kings called the Archimedes to prove it about the gold. So the Archimedes, using his knowledge about the buoyant water, try to explore, try to prove that the crown and the gold was same or not. First, he measured the gold by some stick, same stick. He put the crown at the left side and the gold at the right side, and he tried to scale it is the same way or not. And the scale was hanging up at the end. At the first time, when the crown and the gold in the scale was balanced, it showed that the weight of the crown and the gold was similar the first time. After that, Archimedes takes some water in some place and take the scale into the water. So he put both of them, crown and gold, inside the water. When the scale and also these two things was put into the water, Archimedes found that the weight of the gold is bigger than the crown, because the scale was not balanced. It shows that the weight of gold is bigger than the weight of crown. So he proved, he know that water has special ability. Archimedes know that the water has a special ability to identify every material in this world. He can give the special value of buoyant force, because rho, g, and v. This v was belong to the material. This rho is belong to the liquid. So if the different volume, so the buoyant will be also different. That's why when the king's crown was put into the water, so the scale become unbalanced and show that the gold is heavier than the crown. It means that the craftsman is doing cheating. So the craftsman is doing cheating. So some gold was taken by the craftsman, and the rest was made become a crown. So the Archimedes can prove that the crown was less than the original gold. This is using the equation. So buoyant force was applied into the crown, and the gold was different. This is the different weight between weight in the air and weight in the water. He can prove that if the gold and the crown, he believed that if the crown and the gold was same material, so this will be equal to 0. But if different, the scale will be unbalanced. That's why we can prove that according to, this is the modern science, according to the modern science, the density was equal to 11.3 Sk. So it means that the king crown was not made from pure gold, because he compared between the density of the fluid and density of the gold, and he found that the density of the gold was different, because the density was equal to 11.3. So this is not the density of gold. This is using the modern science. But long time ago, Archimedes cannot do that. He only proved using water phenomena. if you put inside water and the scale was become unbalanced, it means that this is not similar material. So sometimes making crown was mixed between gold and some iron maybe, or using any other additional metal. So this is not a pure gold. Just like a not jewel. Usually men not using. Usually some necklace or some earring and rings using by woman made from gold. Sometimes it is not pure gold. Also in Archimedes' study, he also found the same result like a Pascal. He found that some material put inside the water, sometimes it's sinking, sometimes it's floating, and sometimes it's submerging. Submerging is place between surface and bottom. He not touching the surface and also not touching the bottom. So he stay between them. Similar with the Blaise Pascal study. So according to this condition, he found that the Archimedes force in a sink condition, in a sink condition, he found that the weight is bigger than the Archimedes force. In a floating condition, the weight is less than Archimedes force. And in a submerging condition, the weight and the Archimedes force was equal. That's why the material will stay floating inside the liquid. Then, before the last topic, the last material, also this is the third ability of liquid. It calls as surface tension. Or as surface tension. Surface tension was noted by the Greek symbol. It is a gamma. It's like a gamma equal to F divided by L. L is the length of the material. So gamma is indicate of the surface tension for the liquid. Surface tension will be interact with the molecule of the, especially in the liquid surface. So for example, if some part you put at the surface of the liquid, so the surface of the liquid will give a special tension to protect this part come inside the liquid. But the surface tension was very small. This is according to the type of the liquid. So the surface tension will keep this material not sinking inside the liquid. And using this formulation, gamma is equal to F per L. So if L length was much bigger, so the gamma will be smaller. So surface tension will become smaller. And the surface tension will be highly associated with viscosity of water. And using this, for example, if the material was, the shape was like a ball, like a circle, so the W equal to 2p r is radius of the ball, multiplied by surface tension or gamma, and force that and in using this same formulation we can get the height of the viscosity condition, or we can say that this is the capillarity ability of the water to comes. Water also has the ability to fill into small area. It calls as a capillarity. So the high density of the liquid sometimes cannot enter into the small area because it has a surface tension condition. But the less density of liquid easy to come into the small hole. It's easy to enter and filling into small hole, but high density of the liquid, it's difficult to filling into the small hole. So we call those phenomena as a capillarity ability. So liquid has a special ability. First is hydrostatic ability. So if we give force, he will give the same value of force into everywhere. So this is the first ability of liquid. And second, it has a buoyant force. And the buoyant force is specific and according to the volume or density of the material comes inside the liquid. So in this case, we can say that liquid can identify what material comes into the liquid. So if you put coal or iron or magnesium or any other metal, this liquid can identify what material comes inside me. So he can give the specific buoyant force to rise, to lift this material. So that's the second ability of liquid, and this is the natural ability. And the third one is the surface tension of the liquid. We associate the surface tension with the viscosity and capillarity of the liquid. So maybe liquid is the dead material. It didn't have any shell like us. We have a shell. This is just a body, but inside we have shell. But in liquid, there is some special ability that human didn't have. It has three special attribute. It is hydrostatic, buoyant force, and surface tension. Yeah, okay. Yes. Go ahead. And so I think this is our topic for our class today. So we discuss static fluid. So next week we will discuss about dynamic fluid. Do you have any question?